This GAAIN Interrogator tutorial follows the analyses in our manuscript titled Comparison of Genetic and Health Risk Factors for Mild Cognitive Impairment and Alzheimer's Disease between Hispanic and non-Hispanic white participants. The first aim of this manuscript was to quantify the differences, if any, in the association of APOE genotype with mild cognitive impairment and Alzheimer's disease outcomes between Hispanic and non-Hispanic white participants using existing datasets. To access the interrogator, go to gaindata.org, where you can see our current data partners that are online. Click on Go under the interrogator, where you will be prompted to log in or create an account if you haven't already. 3 data sets were used in this manuscript: the National Alzheimer's Coordinating Center, or NAC, Alzheimer's Disease Neuroimaging Initiative, or ADNI, and the Health and Aging Brain Study Health Disparities, or HABS-HD. Pull these data sets together, click on Create, and name your dataset. Inside the interrogator, you can expand each data partner to view their full list of variables. You can also search for a keyword across all data partners. For example, we can start with APOE. Click on one variable to view the subject count for each genotype, and you can map this to a pooled variable. Choose a new binary variable, and if we want to compare the presence of the APOE E4 allele with the APOE E3-E3 genotype, we need to exclude the unknowns and the E2-E2 and E2-E3 genotypes. Set APOE E3-E3 to 0 and E2-E4, E3-E4, and E4-E4 to 1. Click on Create and name this APOE E4. Now repeat this process for the other 2 data partners. Be sure to choose the previously defined APOE E4 variable under Map 2. APOE returns a few results for HABS-HD. The APOE 4 SMP is the one that contains genotype information. Now that we have our APOE E4 pooled variable, we can go back to our data partners to create an APOE E2 pooled variable. This time, choose a new binary variable, exclude unknowns, set E2-E2 and E2-E3 to 1, E3-E3 to 0, and exclude E2-E4, E3-E4, and E4-E4 genotypes. Although the E2-E4 genotype contains an E2 allele, we already included this genotype in our APOE E4 variable, so it will be excluded here. Click on Create and name this APOE E2. Again, we will repeat this process for the other 2 data partners. To determine the risk of having either the APOE E4 or APOE E2 alleles, we need a diagnosis outcome variable. You can search for squirrel to find a diagnosis variable. This time, we will map to my values, which is a categorical variable. You can keep the labels the same, except exclude the unknowns. Again, repeat the process for the other two data partners. The diagnosis variable for HABS-HD is called CDX_COG. When combining with the other two data partners, make sure that the labels are the same. So NL for normal cognition, MCI for mild cognitive impairment, and AD for dementia. In a full analysis, you would exclude those with a diagnosis of dementia not due to AD, but for now we will keep everything together. Because we're comparing Hispanic and non-Hispanic white cohorts, we also need ethnicity and race variables. For NAC, you can choose either Hispanic ethnicity or Hispanic and map this to a new binary variable where yes is 1 and no is 0. We will call this Hispanic. Repeat this for ADNI, where you can use Hispanic ethnicity or the PT ethnic category variable. Remember to exclude the unknowns. For HABS-HD, choose the ethnicity variable at the top of the list, and Hispanic would be 1 and white and black would be 0. Now we need a race variable. For NAC, choose NAC NIHR. And set white to 1 and others to 0. Name this race equals white so we remember which one is defined as 1. For ADNI, use PT racial category and again set white to 1 and others to 0 and exclude the unknowns. For HABS-HD, use the same ethnicity variable from earlier, and same as before, set white to 1 and black and Hispanic to 0. Now that we have defined our variables of interest, we can begin creating cohorts. We will have cohorts based on diagnosis and race and ethnicity. Choose the diagnosis variable under My Pool Data and click on Create Cohort. For cognitive normal cohorts, we want the cohort type to be at oldest recorded age. Change that and select NL. We will name this NLH, H for Hispanic, because we will further define this cohort. With this cohort still selected, go to the Hispanic variable, select 1 and click on Add Condition. Close out of this cohort and go back to the diagnosis variable. We will create another cognitive normal cohort at oldest recorded age, and this time include non-Hispanic white participants only. After naming this cohort, go to the Hispanic variable and select 0, click on Add Condition. Go to the race variable, select 1, and click on Add Condition again, then close out of this cohort. For MCI and AD cohorts, we can keep the cohort type at youngest recorded age. And as before, choose a diagnosis, name the cohort, and then further define the cohorts by ethnicity and race. After you have your Hispanic and non-Hispanic white MCI cohorts, repeat the process for AD cohorts. Now we have 6 cohorts based on 3 diagnosis outcomes in 2 populations. You can click on each one to review the conditions that were used to define the cohorts. Before proceeding, you can save your pool dataset, which preserves your pooled variables and cohorts. To conduct preliminary analyses, go to the Analyze tab where you can see options for logistic regression, linear regression, Cox regression if these datasets are longitudinal, and Mantel-Hansel meta-analysis if there is more than one dataset. We will use logistic regression here. Simply click and drag your control and case cohorts as indicated. Make sure the control and case cohorts in one analysis are from the same population, in this case Hispanic. Click and drag the APOE E4 variable to the independent variable position. Click on Add Logistic Analysis to set up the non-Hispanic white analysis with APOE E4 in the same manner. With more than one analysis, we need to name each based on the population, so Hispanic and non-Hispanic white. Now the Run Analysis button is active. Click on Run Analysis and review our terms of use, which indicates that the interrogator is to be used as a preliminary analysis tool and you need to request full data from our data partners if you want to complete analyses for publication. Now you can see the results, which are displayed as odds ratios for logistic regression. It shows here that the presence of the APOE E4 allele strongly correlates with an MCI diagnosis for both Hispanic and non-Hispanic white participants, but the risk is stronger for non-Hispanic white participants. This was similarly reported in Figure 1A left panel of our manuscript, where we use full data sets and included covariates for the analysis. You can go back to the analysis setup page and swap out APOE E4 for APOE E2 to determine the protective effects of this allele. The results here indicate that APOE E2 is protective against an MCI diagnosis for non-Hispanic white participants, but not for Hispanic participants, similar to the right panel of Figure 1A. You can also swap out MCI cohorts with AD cohorts and run the same analysis. Here we can see a bigger difference between the correlation of the APOE E2 allele with diagnosis outcomes between Hispanic and non-Hispanic white cohorts, as reported in Figure 1B right panel. You can also swap out APOE E2 with APOE E4 to run the final analysis. Here we see that APOE E4 strongly correlates with an AD diagnosis for both Hispanic and non-Hispanic white cohorts. If you are interested in applying for access to the full data sets, you can find the apply links on the GAAIN Data homepage, where each applied link below each study logo takes you to the respective institutes where you can find more information on how to apply. If you have any questions on using the GAAIN Interrogator, please get in touch at info@gain.org.